In this video, we'll talk about different techniques of solving ordinary equations. So first off, we have separable. So our separable equation will be in this form. G of y prime equals some function f of x. So then, for example, we have sine of y times your y prime equals e to the x. So then now we can rewrite this as sine of y dy dx equals e to the x. So now we just move our all of our y's on one side, all of our x's on the other, and then we get the integral of sine of y dy equals the integral of e to the x dx. So then you take the integral of this and you get negative cosine of y equals e to the x plus some constant. And there you go. That's how you solve a separable ODE. So then our second type of ODE could be a reduction. Typically, you reduce your equation to a separable. So here we have 2x y times y prime equals y squared minus x squared. So now we reduce this to y prime equals y over 2x minus x over 2y. So now that we reduce this, we can let u equal y over x, so we can make this equation become separable. So then you let u equal y over x, then you have y equals u of x, then you have y prime equaling u prime of x, u prime times x plus u. So now you plug that into our now separable function. Well, we're making it separable, so you do u prime of x plus u, which is just your y, which equals y prime. Then you plug in you plug in y, which equals u of x, so you do u of x over 2x minus your x times 2. You have your y equals u of x, so you do 2 times y x. So now you just move these around to get y prime times x plus u equals u over 2, or more than you move this around, you simplify, sorry, and minus 1 over 2u. Then after that, you bring this u over to the other side, and you further simplify, and you end up with u prime of x equals negative u squared minus 1 over 2u. So now this is separable, and you can just use this form. So now we have our linear functions, which would come in this type of form: y prime plus p of x times y equals r of x. Here's an example. We have y equals e to the negative h, the integral, all times the integral of e to the h r dx plus c. H equals the integral of px dx. So then you get y prime minus y equals, so here's the example, sorry. So here's an example for our linear. So we have y prime minus y equals e to the 2x. P of x would equal minus 1, just because there's just minus y there. R of x equals e to the 2x, because that's what we have on the right-hand side. So then you go to your h equals minus the integral of 1 dx, which turns out to be negative x, and you plug everything together and you get y equals e to the negative h times the integral of e to the h r dx plus c. So right now we're just plugging these values into here, and then we solve e to that if we solve, and it turns out to be e to the x, the integral of e to the negative x times e to the 2x dx plus c. And we further simplify, and you end up with y equaling e to the x times e to the x plus c. So now we have a different type of function, which will be our nonlinear ODEs. And for this case, you'll have some type of function that will look similar to this, y prime plus px times y equals gx y to the a. So it's nonlinear if a is greater than 1. So that's when y is raised to some power greater than 1. So here we solve it by letting u equal y of x all raised to the 1 minus a. So then u prime will equal 1 minus a times y to the negative a times y prime. So then we just go forward and keep solving to get 1 minus a y to the negative a times g y to the a minus py. Then you get 1 minus a times g minus p y all to the 1 minus a. So this y to the 1 minus a is our u term. So now we go in and plug u prime equals 1 minus a. All we're doing here is g minus, and now instead of p to the y, 1 minus a, you plug in your u, so then you end up with pu. And therefore, this is linear. So now that we have a linear equation, we can make this, we can do it as shown in the previous technique of a linear ODE. So then after that, you just solve for your y prime equals a y minus by squared, where a and b are constants. A equals, so here we'll just say a equals 2. Then you do, so y prime plus your px, y, g of x, y to the a, you get, sorry, this is an example. So then you let u equals y 1 minus a, which equals y to the negative 1. U prime equals negative y to the negative 2 times y prime. And then you get negative y to the negative 2, ay minus by squared, which equals ay to the negative 1, which is just our u, plus b. So then we just do u prime equals a times u plus b. Thank you for watching.